Hi, my dear student. Good morning, everybody. Here I am Dr. Biswajit Gayan, Assistant Professor, Department of Chemistry from your college, Dr. Sudhit Chandrasur, Institute of Technology and Sports Complex. Student, we have already gained some idea about entropy and the function and the change of the entropy, and from that we can say about the success of a reaction, that is the reaction will be happen or not. In another word, we can say about the spontaneity of the reaction. So by measuring the entropy change, we can say about the direction of a reaction. But the change of the entropy, not the final conclusion, because there will be other parameter which are present, and here Gibbs free energy is another function, another free energy function, which ultimately offer the spontaneity of the reaction. So by checking the Gibbs free energy or measuring the Gibbs free energy, one can say full and final about the spontaneity of the reaction. So we need some idea about the Gibbs free energy, and we are try to correlate this Gibbs free energy with the spontaneity of the reaction, or one may can say the direction of the reaction. Mainly in the chemical or in the chemistry, a chemical reaction, yes, there will be lots of chemical present, but if we take two chemicals like A and B, now whether it will be react and produce C or not, that can be determined by the simple function or the change of the Gibbs free energy. And now we want to enter into details about the Gibbs free energy. Before entering into the details, I want to describe some preliminary thing about the entropy. So that is the recap. So here, entropy of the universe. Entropy of the universe and its spontaneous processes. If the total entropy change of the universe is positive, again, if the total entropy change for a universe is positive, then the process will be go forward, because the for a particular reaction, the change of the entropy of the overall environment should be positive, otherwise a system cannot be fruitful, or the system cannot be performed properly. In case of the chemical reaction, it will be not happen. Now, yes, the entropy can say about something about the direction of the reaction, but not properly or finally. But we want to take the help of Gibbs free energy, and here the Gibbs free energy again correlate with the entropy change, then we'll get result which is very convenient in terms of its direction and its success. So delta S is not so much convenient as like delta G or change of the Gibbs free energy. Basically Gibbs free is nothing. Gibbs free energy is a function, and the great scientist Gibbs proposed that, and a new thermodynamic state of function, because Gibbs free energy is a state function and derived from the three other state function. That is, Gibbs free energy is a state function, and it is the expression of the free energy, and it is a function of three state function which are enthalpy, that is H, entropy, that is S, and temperature. So Gibbs free energy is a function of H, S, and temperature. So Gibbs free energy can be written as a function of H, S, and T. Now Gibbs free energy. So Gibbs free energy is defined as in the proper way as a function, that is G. G is denoted by Gibbs free energy. G is equal to H minus Ts. You have already know about the H notation. Here H is the enthalpy, T is the temperature, and S is the entropy. So student, please note it that the Gibbs free energy expression is G is equal to H minus Ts. Now if we want to measure the change of the Gibbs free energy, then the equation will be as like this. So Gibbs free energy change for a given process is written by del G, because you know that the del G means the change of the Gibbs free energy, and then del H obviously, that is change of the enthalpy, then minus T del S. Here we are not considering the change of the temperature, that means the process is at thermal equilibrium, or we can say it is an isothermal process we are considering. So del G is equal to del H minus T del S. This is the general form of the Gibbs free energy at constant temperature and process pressure. Now change of the entropy and Gibbs free energy. So we will understand about the change of the Gibbs free energy and want to correlate the chemical reaction. So entropy S is maximum at equilibrium. So if we consider the small change and infinitesimal change for a process at equilibrium, the number of the infinitesimal change will be maximum, and that's why as the entropy is the representation of the randomness of a process or randomness of a material, so entropy will be maximum at equilibrium. But on the other hand, if you come to the expression, if entropy is high and just before there is a negative sign, so if del S is very high or maximum, then del G will be minimum at equilibrium. So in case of the entropy, del S is the maximum and del G is the minimum. So one can say when del G for a given process is negative, because if del S is positive and high positive, then the final expression should be negative, because only the positive term is here, the del H. So now del H may be negative and positive. There will be lots of condition about this equation, but in generally for a spontaneous process or equilibrium process, del G will be the low value, and for a spontaneous process it will be negative. For equilibrium it will be 0. Now we will directly predict the spontaneity of a reaction by using del G. Del G will be negative, that means the process is spontaneous or the reaction can happened can be happened, or otherwise the reaction will be go forward. Now positive delta means the process is not spontaneous, or the process will be not taking place, or one can say the reaction will be in the reverse direction. If del G is 0, then the reaction is at equilibrium. So student, please note and remember it, 3 point. If del G is equal to 0, that means the process is under equilibrium. If del G is negative, so that means the reaction is spontaneous or the reaction is successful. The reaction will be carried on. But if del G is the positive, then the reaction will be not happened, but you can say that is another way, the reaction will be occurred in the reverse direction. So here is a table about the different type of this process and the sign of the del G. Before we want to discuss about this table, I want to taking some different cases of determination of the del G where the del H and del S value are different. Now case 1. In the case 1 we are considering del H is negative, that is endothermic reaction. Del H is negative, that means exothermic reaction, and del S is positive, because obviously, because if the del S is not positive there will be no reaction. So del G, so if del H is negative and del S is positive, so according to the expression of Gibbs free energy or the change of the Gibbs free energy, del G is equal to del H minus T del S. So here if you just include the sign, del H is negative, now in T del S, so there will be a negative sign, and del S is positive. So both the two term, that is del H minus T del S, both the two term are negative. So ultimately you will get a negative value of del G. So as we have know that it if the del G is negative, then the reaction will be spontaneous at a temperature T. So, what are the condition? If del H is negative and del S are positive, then the reaction must be spontaneous. So now we will discuss about the case 2. Here del H is positive. Here just opposite of the first case, that is del H is the positive and del S is negative. Del H is positive and del S is negative. So if you go to the expression, that is del G and del H, so here del H is the positive and del S is negative, but in the term T del S there will be a negative sign, so ultimately it produces a positive value. So ultimately del G will be positive value. So as the del G value is not negative but it offers some positive value, so in this case, on this type of the process or in this type of the reaction is not spontaneous. This reaction will be not happened. Now case 3. In case 3, del H is positive but del S is negative. Del H is positive but del S is negative. Sorry, again I am so sorry. Del H is positive and del S is positive. So again from the expression, if del G is equal to H minus T del S, here first term, that is del H, is positive, and as entropy is positive, so the second term offers some negative value. Now if the second term is a higher value compared to the first term, that is del H, then the overall function or overall value of the del G will be negative. So the second term will be higher if the temperature is very high, then the value of the second term will be bigger. So in that case, this type of the reaction will be spontaneous if the temperature is very high, but this will be not spontaneous if the temperature is low. So this type of the reaction are temperature dependent. So the fate of a reaction of this type, when the del H is positive and del S is also positive, then the fate of the reaction will be determined by the temperature of the system. Now another case, that is case 4. Here del H is negative. Yes, very good, the first term is negative, but del S is also negative. So the del G will be negative or positive depends on the temperature. Now if the first term value is high compared to the second term, then it will be spontaneous. So if the temperature is low and very low enough, then the second term value will be low and it will be ultimately give the positive value. So as the del H value is negative and it is more negative than the second term, so it can produce a ultimate negative value of the del G. So in that case we can say yes, the reaction will be carried on. But if the temperature is very high, then the value of the second term will be higher than the value of the del H. So in that case, the value of the del G will be positive. So in that case, the reaction will be not go forward. So when del H is negative and del S is also negative, in this type or in this situation, the reaction will be occur at low temperature, and if it is carried on the higher temperature, then there will be no success. So now if you again come to the table, so it will be summarized in the table. We'll get this. So here there is summary: sine of del H, sine of del S, sine of del G. So if the sine of del H is negative and sine of del S is positive, so ultimately the sine of the del G will be negative, and in that case the reaction is just spontaneous for all temperature. But if the del H is positive and del S is negative, so the sign of the del G will be positive. But this type of the reaction will be this type of the reaction will be non-spontaneous at all temperature when del S is positive and del S is negative. So both the two terms in the del G expression will be positive. So this type of the reaction are non-spontaneous. But if the del H is positive and del S is also positive, then there will be two possibility. So this type of the reaction spontaneous in the higher temperature, but in the lower temperature this will be no question of the spontaneity. Again, if the del H sign is the negative and del S sign is negative, then there will be two possibility. It will be spontaneous or may not be spontaneous. So it will be spontaneous if the temperature is low. So this is the summary of the spontaneity of the reaction by using the function del G. So I hope that you understand the spontaneity of the reaction by measuring the value of the del G, and you can correlate the spontaneity of the reaction with del G. If you have any queries or any problem, please inform me. And lastly, thank you students for your kind attention in this class, and take care.